Hello guys, so I am continuing this video with how to find charges on the periodic table. And so I suggest you watch this video, but I'm just going to go into it briefly. Okay, so we have, you have your periodic table, and in this group, your charge is going to be +1, +2 for this group. Our transition metals vary, and I'll show you how to figure that out later. So I'm just going to put those in purple just to show that we're not going to worry about them right now. And we can figure out their charge based upon what they are bonded with. So we can figure out their charge. Alright, and here you have plus or minus 3, or no, actually +3, sorry. I'm getting ahead of myself. +3. The next one is plus or minus 4, and I'll talk about why in a minute. This one is -3 for this group, -2 for the oxygen group, -1, and then 0. And so why are these charges like this? Well, remember in the last video I talked about the number of valence electrons, right? And so you have, and so I'm going to put valence electrons down here. Let's do valence electrons, right? This group has 1, 2, 3, 4, 5, 6, 7, and 8. And so when we view, so I'm going to do a shell with 2 electrons for our hydrogen and helium. So this is going to represent hydrogen and helium. Well, helium's already happy, but let's see. And then let's do one with 8, right? And do one with 8. And so when we see hydrogen, right, it only has 1 valence electron. And so let's, for a second, just erase that. So this is hydrogen, right? And so what hydrogen can do is it can either gain 1 or lose 1, right? So it gives away this electron, right? It gives it away when it's in a bond. Or we can talk about, instead we can talk about sodium. That might be a little bit easier. That outer shell only has 2 valence electrons, right? And only has 1 valence electron. And in order to get to that next energy level, that only has, that would be full. And so let's draw that out so I can explain it better. So let's draw out sodium. And so sodium has, we can see 11 electrons total. Okay, so sodium has 11 electrons total. You have that first shell that's going to have 2 electrons, right? Because that's all it can fit. Then you have the next one that's going to have 8. Right? And then we get into this third energy shell. It has 1. Right? And remember, shells like to be filled. This outer shell is not very happy because it's not filled. And so in order to get to a filled energy shell, it can either gain 7 to fill in this one, or it can lose 1 in order to get to this one down here that's more stable. Well, what's going to happen is, I try to think about it as hiring people. Is it easier to hire 7 people, or is it easier to fire 1? It is easier to fire 1. And remember, with electrons, we say when you lose an electron, things become more positive. So we lose 1 electron to get down to this more stable energy shell. And so when you do that, right, we can delete this whole outer shell. It's not needed anymore. And so now it's happy and it has a +1 charge. because it lost that electron. Remember, when we lose electrons, losing electrons is like losing that negative coworker. Things become more positive, right? And when things become more positive, then you have that, and you only lost one electron, you gain one positive, so that's where this positive 1 comes from. Okay? And so if I went over to the next one, magnesium, right, and did that one the same way. So if this is magnesium, right, and there's 12 electrons, and so there's 10 now, and then I do that outer energy shell again. Right, now we have 2 in this outer shell. Okay, and so it's easier to lose these 2 than to gain all the ones it needs to fill up this shell. And so it loses 2, things become more positive by 2, so it's plus 2. And it goes down the same pattern. If we move over to aluminum, you would have 3, and it's easier to lose 3 than to gain all the electrons you need to fill this outer shell. Oh wait, I think this outer shell is 18, not 8, sorry. But still, it's easier to lose than it is to gain. And so, when you get to carbon, for example, you have 4, and I'll show you why it's plus or minus 4. Okay, so when you get to where, and I'm just going to draw the outer one this time. All right, 1, 2, 3, 4. It's just as easy to gain 4 as it is to lose 4. It's just as easy to hire 4 people than it is to fire 4 people, right? And so that's why it's plus or minus 4, because it's just as easy either way. Now when you get to nitrogen, it's easier, and if we assume like that outer energy shell only has 8, right? So nitrogen has if that outer energy cell is 8, right, and it has 5 valence electrons. 1, 2, 3, 4, and we'll just put a 5th one here. Right? It's easier to gain 3 than it is to lose 5. It's easier to gain 3 than it is to lose 5. And so it only has to gain 3 more electrons to get to 8. And so because you gained 3, you hired 3 negative Nancys, then things are more negative by 3, but at least now we're full. Okay. And so that's how, that's why these charges go the way they do. If it's good to understand this and understand why, that way, like when you get to Chem 2 and maybe all your tests aren't take home, or when you get to your final and it's not take home and you have to take it in the classroom and you forget and you don't have this memorized up here, then you can reason to yourself, well, I know this is plus 1 because of the things that we've already talked about. It's easier to lose 1 than it is to gain the 7 more that you need to fill up that to 8 if it's in that second energy shell. And so, but if you just want to memorize this the way it is, that's what I did when I was in Gen Chem 1 because I didn't have the best understanding. So if you want to memorize or if you want to reason through it, do it the way that you're most comfortable doing it. Okay. Now in the video, they won't show this part where it's like plus or minus 4 in this video, because when you get down here, things can get a little finicky in terms of, especially if it's a metalloid and stuff like that. So, but don't worry about it. Usually, for this one, I would just give you like carbon or silicon, something up here where it's obvious what it is. And in the video, it'll say like these are like either like I think a +1 or +2 or +3 or something like that. Usually metals tend to be positive because they want to give up that electron. For transition metals, I don't expect you to have these memorized. Okay, we're going to be able to figure these out anyways based upon what it's bonded with. And so let me erase this stuff and just leave the charges, and we can do some practice. Okay. And maybe I'll just draw those charges a little bit better. So we're going to erase this, and we're going to do a little bit of practice, and then I'm going to have you pause the video and practice on your own a little bit. And that's the same thing that video in the previous slide asked you to do. So between this video and the video link here, you should have plenty of practice. Okay. So let's do here. You have, remember, this was +3. This was plus or minus 4. I'd write that a little bit better. Plus and minus 4. Minus 3, minus 2, minus 1, and 0. Okay, so I'm going to write a few up here, and then I want you to try it on your own. Remember, these numbers on the bottom are valence electrons, but I'm going to erase them now that I'm done with that explanation. Right? So I want you to pause the video, try it, and then, you know, if you get it wrong, nobody knows, because I'm assuming you don't have an audience watching you. So try it on your own. This is where you get to get it wrong for free. So I'm going to write lithium, nitrogen, and argon. So what are the charges of these? Pause the video and try it. So I'm assuming you tried it. So lithium is here. Oh, let me draw that a little bit better. Lithium is here, right? So that charge is going to be +1. Nitrogen is here. So that charge is going to be -3. Argon is here, so that charge is going to be 0. Okay. So let's think about what might happen, though, how we might find the charge of these transition metals. Right? And so if I gave you a compound like oh, let me erase those out, these marks too. Like let's do, this one is also talked about in the previous video. Let's do FeCl2. Okay, how am I going to find the charge of iron? And I'm going to write this here, Fe, so that way we have some room. Okay, so the first thing you need to know is your charges need to add up to 0, unless it's unless the compound is charged, which it's not. And so the way I show people how to do this, there's like more of a shorthand method in the video. I show you kind of a longer way. It is a little bit more tedious, but I do that because it's not always going to add up to 0. Sometimes it can add up to -1, and so I kind of have a formula to show you how to do it. When it adds up to 0, you don't necessarily need the formula, but I'm going to introduce it as though you do. That way you can get the idea of how to do it from the start. So if it's FeCl2, for example, you have one Fe atom, one iron atom, okay, and you have 2 chlorine atoms, right? And that has to equal 0. And so I start off with putting 1 times the charge of Fe plus 2 times the charge of chlorine has to equal 0, right? But what's the charge of chlorine? -1, okay? So I just, because we don't need this 1 in front of here, and we're kind of more used to using x as an unknown, I replace this with x. So x plus 2, and our charge of chlorine is -1, equals 0, okay? And x minus 2 equals 0, and so we're going to add 2, right? That's going to cancel, and so x equals +2, and that's the charge of iron in this case. Okay, and so we will call this iron 2 chloride. And we'll get into how to name a little bit later, but you can't know how to name until you know how to find the charge, because particularly with the transition metals, you have to be able to find the charge to know what this Roman numeral is. So with transition metals, you have this Roman numeral in the middle.